Hey people, see this LED blinking? Super simple, right? But think for a second. How does this light know when to blink? Who is giving the commands? And more importantly, how is that command even reaching the LED? We always say CPU sends the signal. But how? How do two electronic components or two chips actually talk to each other? The answer is UART. As we took the example of LED blinking, the communication will be between the main CPU chip and the LED. Chips and other electronic components use protocols to communicate with each other. In those list of protocols, UART is an important one and widely used inside chips. In this video, let me explain how this LED knows when to blink using UART protocol for communication. Let me try my best not to make it as a lecture. Now, let's think this communication as a normal scenario. We know both CPU and other components in the system runs based on the global clock. But we can't say the communication will be only inside the same system. The communication will be between two different chips or two different systems running on different clock. When we send some data or command from one chip to another chip on their own clock, say for example, chip A will be sending the data with speed 1 bit per second and chip B will be sending the data with the speed 2 bits per second. It's like chip B will expect 2 bits on 1 second, but chip A is only sending 1 bit a second. So there will be a collapse or a misunderstanding between them. To solve this problem, UART was created. UART has its own clock called baud. See this block diagram, it's UART. It will have its own baud generating module which will create a common baud rate between two chips or two systems with the help of the global clock. If the communication is inside the same chip, then global clock will help. But if the communication is outside the chip or between two other chips, then the other chip will be set to the same baud rate using the baud generating module it has on its own system. Once baud is ready, it will be set as clock for both the transmission and the receiver block. Those TX and RX blocks will load the data and send them one by one serially, based on the baud rate that is set to it. There will be a dedicated channel called TX done, which will act as a flag and will be set high when all the data is sent, like telling the receiver that I have sent all the data, so stop receiving. Now wait, so the receiver knows when to stop listening and actually stop receiving the data. But when does the receiver know if data is incoming, like when to start listening to it? The TX channel that is used to send data in zeros and ones, it will send a start bit 1 before sending the actual data. Like say, we need to send 1010. Then the TX channel will send the signal as 11010. So as the TX channel will stay at 0 all the time, when the receiver sees 1, it suddenly starts to receive the data from the next bit. So this is how UART protocol works. Now you can see the inside working of how two chips communicate with each other. And for the LED we talked about, it won't use UART directly because the LED does not need UART. But without UART, the blink signal won't reach the LED. So without UART, there will be no LED signals. There are different protocols like UART used for communication between chips like I2C, SPI and more. They too won't be interacting directly with the chips. They use something called bus. And that's the different topic for another video. If you find this video useful, drop a like and comment down. That will be so helpful for me to make more content such as this. If you are into VLSI and electronics, subscribe. And if you want to learn more about such kind of topics, follow me on Medium to read about it. We are also building a Reddit community to share weekly updates too. All the links are in the description. Thank you.